Oh, this is recording. Okay, review set 9B, question 15. Last question in the book, I think. How exciting. It's over here. Community group wants to reduce speed limits to 40. 40? Why stop there? Why not make it 5 kilometers per hour? Anyway, the survey shows that over 50% of households wish to change the speed limit is required. Okay. Anyway, so the council have said they want a survey showing 50% of households. So that's a proportion, right? They contact 70 households, 37 say they want the speed limit reduced, construct a confidence interval for this proportion. Hey, we could do it the long way, but we're probably just going to use the calculator for that. So our sample proportion was 37 out of 70, which is over half. But if we set up a confidence interval, 95%, I'll just write CI for confidence interval for this proportion, right? We have to base that off the sample proportion, and we'll need to plus minus the z-score times the standard deviation. So it's P1 minus P. I might just write P1 minus P because I don't want to write the fractions. On the n is 70. There we go. And we'd have to go the other way as well. I probably should be writing 37 on 70. No, I'll do it this time. Got a bit more space here. So the 37 on, these are the sample proportions we're basing this on. 37 on 70, right? The complement to that is 33 on 70. So that's the 1 minus P. Then we're dividing it by 70. Okay. Oh, I forgot the 1.96. I have to times that by 1.96. That's how we set it up. But like I said before, we could go to the calculator to do this for us. So clear that. We go test. So stat tests. We find our one prop z int 37 out of 70. Confidence 95. It's always worth double checking that. We get a reasonably large interval actually. 0.412, 0.646. Can I remember that? 0.412, 0.412, and 616, I think I said. So we are 95% confident that the true proportion lies between about 41% and 61.6%. Right? It's probably not going to convince the council. The council might not be satisfied. If the council is looking at the confidence interval, they might not be satisfied because what the interval is saying is that the true proportion could be as low as 41.2%, and the council wanted it to be 50%. Right? So you could say something like 0.5 lies inside the interval. Right. We do not have evidence that P, evidence that the true population proportion P is greater than 0.5. I don't know why I wrote 5 there. 0.5. Okay, because it could be down here in the 41. So we're 95% sure it's in there somewhere. Okay. Council insists they need an interval of 0.05, which is much smaller than the interval we had. So it's going to need a much larger standard deviation. Why do you think this? Well, see, this maximizes your, when you come to work out the standard deviation, right, the largest value you can get is from sample proportion 0.5. So that's one reason why you should be using, use, well, they write P star equals, so this is an unknown proportion, and that's part of the answer. So because the P is unknown, but it's also worth noting that P1 minus P is maximized if you use that value, right? If you do half times a half, you'll get a bigger result than if you're doing this one, for example. Like if I had a quarter, say P was 3/4, 1 minus P is a quarter, what happens? I get 3/16, right? But if I did a half times a half, what happens? I get a quarter, which would be 4/16. This is always the way to maximize this standard deviation calculation that we have to do in our confidence interval. So it forces you to spread the interval wider, if you will, and make sure that you've got enough samples. So it's a legitimate thing to be doing, because really we want the n, how many samples, but we don't know what the true P is, and we don't want an n that's too small, hence we would use P as a half. To work out n, given that the width is easy to figure out because it's this minus this to get the width of our interval. So the width is 2 times 1.96. You'll have this written down. As you can see, I'm needing to work it out from principles here, if you will. So let's have a look. If we had width on 2 times 1.96 and then we squared that, so I'm pulling this over here, we're dividing both sides, we're squaring, we're left with P1 minus P on n. So what we really want is the n by itself, so maybe we could just say that 1 divided by this equals 1 on n. Swap these around and then flip them. So our n will be 2 times 1.96 on W, which they've told us, squared. And just use the formula for this. That gets flipped around. And this will be on the bottom. So will be divided, multiplied. I'm trying to do too much in my head here. Yeah, multiplied, half times a half. Right, so the P times 1 minus P will be half times a half. We could go to the calculator with this. So what are we doing again? 0.02 times 1.96 divided by 0.05, then we're going to square that answer, squared, then we've got to times it by a quarter, and we need 1536.6. Now that's at 5. I've just quoted 5 significant figures. 1,000. Hang on. If we did 3 significant figures, we'd have 1,540 approximately. So I should be writing approximately. And I'm always rounding up, right? Because we want to make sure we have enough people. 1,540 people, 3 sig figs. Okay, so your rounding is based on 3 sig figs, and you should have noticed that the book does that. Okay. Right, so anything else to that question? The survey to satisfy the council's requirement. About 52.9% of households said they wanted the speedometer. How should the council react? So you could set up a new confidence interval in the same way that you did in part A. Right? I mean, let's have a look at it. I might have to clear the screen. 52.9%, and I've got to remember this number, 1,540. 1,540. So what is 52.9% of 1,540? 1,540. I'm just, because let's see if I can use the calculator. Let's do 815. So maybe you should do this the long way, and I've pressed the wrong button as well. 815. Because if you're using the calculator, you have to know the actual number of people. 1,540. Yeah, so that's looking better. So this gives the council confidence because the population proportion, we're 95% sure that it's between 0.504 and 0.05 above that. The council wanted it to be greater than 0.5. So this would be evidence. You'd write a statement. The population the proportion 0.5 lies outside the confidence interval. There is evidence to suggest that the true population proportion is greater than 0.05. Okay. Now that's a little bit of an estimation what I've done there. You can see I don't have the proportion they said, 0.529. I've done a bit of a fudge. So you might want to use the full formula. To be a little bit more accurate, but what I was hoping would happen has happened, in that having this slightly out, not changing the conclusion, that this does provide evidence now that we've got our numbers up, although these people now have their work cut out for them because they've got to go survey over 1,500 people, so sucks to be them. Okay, that'll do. That last bit's really similar to what happened in part A, so I think me rushing through that is okay.